All right, so let's do one more of the similar example with maybe different limits on the voltages and on the resistors. So let's say we have 3.3 kilo ohms resistor as the primary resistor R1 and 1.5 kilo ohm at the load. Problem usually asks, draw the output waveform on the load resistor. That's usually how the problem is asking is draw the waveform across the load. It's the same circuit, so that's the given. So that's the given orientation. Same thing, drawing the voltage waveform on the load. So usually that's the problem statement. Draw the voltage on the load waveform. And sometimes it's usually be referred as to draw the output waveform. It can also be say draw the output waveform. Remember, the output is always means all the way at the end of the circuit. What? When you're talking about positive cycle. When you're talking about negative cycle, then the top would be negative. For which one? Yeah, that is which one you're saying. You're talking about the source. Source is an AC source, so depending on what cycle you are talking about. That's what I'm saying. When you talk about positive cycle, the top would be positive. When you talk about negative cycle, the top would be negative. You need to talk about both cycles to even solve the final answer. Do you see what I'm saying? If you say, okay, I'm going to go with positive cycle first, then you put positive and negative right there. That only indicating that you are talking about positive cycle. AC source doesn't have any positive and negative as of polarity.
It kind of does, because then you don't know what side to flip. You know what I mean? If it's coming in, if the bottom is positive, then top is negative, and then you know what I mean?
That's you need to show on your work. It doesn't necessarily need to show on the circuit. Because AC cycle means I don't even need to mention that. I don't even need to indicate right here what is positive and what is negative. Oh no, let me clarify to him before I even. Does that make sense?
So if R1 is on the bottom there, it would then be a negative flip.
No.
You know what I mean?
Don't change the orientation of components. The R1 should be right there. But even if you put it at the bottom, for that matter, it's still going to be a positive clipper. So just for sake of discussion, if you throw that R1 right here, it still be a positive clipper. Which side is being clipped is decided by the diode, not by the R1.
But the diode would be in reverse at that point. Because the R1, reverse bias diode, load. You know what I mean?
It's either, you're not seeing it right. This is an AC source, correct?
Yeah.
Agree? So which cycle AC source have?
I understand it has both.
So
however, one side is the positive and one side is the negative.
no, it's not going to be like that. So If you say positive cycle for AC source,
I just want to know when it's starting the top first.
you can start either way, but I usually start with positive, going up. But you can say, okay, no, I didn't like it, but I'm going to start here and I'm going to go down. That won't even affect it. You see what I mean? Because even if you start here, your analysis, okay, I'm going to go with negative cycle. No one will stop you. But eventually you will come back to the, you see what I mean? So if you start with positive, eventually the signal will come back to, when you start with negative, eventually the signal itself will come back to the positive. But as long as you provide both, because the signal has both positive and negative. So for example, if you deal with DC, then you need to indicate, of course, by longer line automatically means it is a positive, correct? So for example, if I have a DC like this, then I must know that this is not going to change, correct? This is like the signal shape is positive here along the time. Here, what is the signal shape? The signal value will be negative, which is not going to change from here to here or here to here. But AC signal means if you start with positive, again, there is no indication that you should go up.
Why does flipping the diode have to do it? That's both sides of the positive and negative. You know what I mean?
I didn't get your question. So what?
What I'm saying is,
I'm not flipping the diode.
if I flip the diode, it should
Why you want to flip the diode?
change.
Why you want to flip the diode?
I'm just, because I don't know which direction it's coming out of. That's what I'm saying.
The diode direction is given and you don't change the diode direction.
Well, what makes it positive that way? If I flip it over, it doesn't matter because you can flip the polarity.
Again, do not jump ahead and try to talk about flipping the diode. Just for now, we're going to talk about that, what will happen in the later coming slides. What happens if I flip the diode over? But what is flipping is not the diode. The source is flipping back and forth. That causes the diode forward or reverse bias. The diode orientation is still in the same direction like you put it in the circuit. Diode is alternatively become forward and then reverse. So the biasing on the diode is becoming forward and reverse because the cycle is changing, because the source is changing, not the diode is being flipped over. What will happen if you flip this over? That's a discussion for the next coming slides. So again, we are only working on this circuit. The more it confuses you to, if you think, okay, there is nothing wrong to think about that, but it will confuses you a lot without even putting the pen on the paper to exactly see what happens. As I indicated, clippers are not easy that you can even draw just visually seeing it. So unless you put it and draw it, it's very hard to even visualize it until you get some experience on how to deal with it. But flipping the diode, we will definitely talk about that and why it does what it does when you flip the diode over. But it's not going to be like this when you flip the diode over. So we are not changing the orientation, but the diode itself is becoming forward and reverse bias alternatively. Does forward biasing means flipping the diode? Or does reverse bias means flipping the diode? No. So why the diode is becoming forward bias and then reverse bias and then forward bias like this? Because you have the source AC Are we changing the AC source to go back and forth? That's the nature of the AC source, to go back and forth. So we're not controlling the AC source. When you say AC, it does it automatically. We're not touching the orientation of the diode. This is still a positive clipping. It cannot make a negative clipper. This one itself is a positive clipper. So it's hard to tell. There are ways to tell by look of a circuit whether it's a positive clipper or negative clipper. And that confuses you a lot too, if I tell you. Because depending upon whether the circuit has only one diode or a diode with a DC power source in series with it. See that? That's a little harder to imagine. We will go over, because there is a concept called as different values of clipping, but it will confuse you even if I show. If you want to visually see it, think about a diode in series with a DC power supply in that branch, wherever the diode is. If you have like that, then it's really hard to visually tell whether it is a positive clipper or a negative clipper. But if you don't see a DC power source, if let's say there is no DC power source in the circuit, if the diode is facing downwards, that's a positive clipper. If the diode is facing upwards, it's a negative clipper. Again, we haven't talked about negative clipper yet, correct? But this one we just talked about it, which is a. We will talk about it right after break. So we will start that as a negative clipper. So there is a concept for negative clipping, but this is only a positive clipper. So, and we will come back to that negative clippers and see. But you should find out yourself actually, if you really know what is forward bias and reverse bias, if you actually draw exactly like what the process is. So remember that the process, you begin with the given source, correct? And if you're interested, you can flip the diode and actually follow exactly the same way to find out what will happen if you flip the diode. But according to, I'm going to finish just this example. So positive cycle on the source. So that's positive cycle, that's a negative cycle from the source perspective, right? So it's the same exact example like previous cases. So, but what is the next step that you should do? That is correct. The next thing you should find out is the polarity of the diode. This is always going to be step one. It's just you are telling yourself that, okay, I'm going to work with positive cycle. I'm going to work with negative cycle. And then the second step would be, okay, what's the given orientation of the diode? And you just put the positive and negative on the given circuit. So if you've done that, then the third step would be, okay, now the positive voltage, positive cycle means we are talking about positive voltages. What type of biasing the diode is according to given orientation? It's a forward, because this is positive on the top and you are talking about positive cycle. And automatically this one would be negative cycle. That means negative voltages on the positive side of the diode. As you see that this orientation is not changing. The step number 2 is given always.
Is the positive cycle always at the top on the drawing?
That's usual sense.
Okay.
When we're drawing sine waves,
How did I know if it was a positive cycle on the top or negative cycle on
positive means positive values. When we say positive cycle, we are implying this is a full cycle, correct? When we say positive cycle, it's a collective term for voltage values between these 2 points.
And that always comes at the top.
Since it's above x-axis means all are positive values. That's why it's a positive. This is a collective term that represents that whole cycle. Since they are above the time axis, it's positive. That's why the voltage levels are positive.
Yeah, my original question was, is it positive cycle coming at the top or is it negative cycle coming at the top? And you were like, it doesn't matter. But I guess I didn't say cycle.
Because your question to me is kind of vague. I really didn't see what you're saying. But the reason why we call positive because it's above the axis. But again, as I said, there is nothing stopping you, okay? Does this still works? Of course it does. Right? So in here, since these values below the axis, those are all negative values. That being said, like a negative voltage coming in. So if you once decide forward or reverse bias, then after that it's usually be pretty simple. Forward bias means you're going to have 0.7, but most important point in here is the orientation of the diode. Where in here, the positive of the diode is on the top, negative is on the bottom, correct? So that means the voltage that you are looking at is the positive 0.7. So the signal basically goes to positive 0.7. That's why it was above the time axis again. So let's say that's my axis. This is just the diode. I didn't draw the whole circuit, but you could draw the whole circuit, but that's just the diode. Do not even go flipping that diode yet. We already talked about it. If you remember day 2 on the rectifiers, refer your notes back onto the day 2 on the half-wave rectifiers when we flip the diode. We even did this in the yesterday's lab. If you flip the diode, what happened? So in here, reverse bias is always, no matter what, which cycle make it reverse bias always gives you a voltage divider because the location on the diode can be presumed as it's an open circuit. So it's always going to be a voltage divider. So the voltage on this load resistance, which is the 1.5K, so the interested resistor is 1.5K over the total resistance is 4.8K, which is the addition of those 2 times whatever the source voltage is. Again, remember you're performing this for the negative cycle. So the outcoming voltage would be negative as well. So whatever that voltage limit would be. So how much it came out?
3.125.
So 3.125? It's the same as before. All right, so let me multiplied by 10. So 1.56. So the resultant signal, since you are under negative cycle, so the resultant signal peak would be at negative 1.56 volts. So that's the given, or that's the output signal that we are looking at off of this clipper. Again, this is still a positive clipper. The orientation of the diode is still facing downwards. All right, so any questions on about this type of circuit? So any questions on this positive clipper, on how the clipping action would be?